Hello everyone, today we are starting with CS50 cybersecurity course, okay? We are going to do the week 0, the first assignment 0 from CS50, okay? In this course, the assignments will be a little bit different from the usual ones, CS50 Python, X, because you are going to answer the questions on Google Forms, okay? They are more theoretical. This is actually a video to help you understand a little bit of those concepts if it's a little bit hard to understand by yourself, okay? We don't encourage any of you guys to copy these answers and just send the assignment, okay? But we don't encourage you to use them. You can create the answers by yourself. In this way, you are going to simulate much easier all of the concepts, and you will have a fair grade after your test, okay? So first of all, you guys can watch the lecture from securing accounts. In the first assignment, we are going to deal with some basic cases and concepts of password, complexity of passwords, balancing your password to be secure and at the same time be easy to remember, for example. And we are going to deal with some kinds of attacks that a person can be a victim online nowadays, and authorizing a person to access the information from that website, right? Okay, so let's get right into it. So in the week 0, securing accounts, just like I said, we are going to take a look at some things: authentication, authorization, usernames, password, attacks, right, two-factor authentication, and some other things, right? You can take a look here in the assignment 0. You can take a look at the notes as well. We are going to use the notes to explain some things, some concepts, and we are going to have as well the images in the video, okay? And then we can think in a good solution, a good answer for our problems. So let's open our assignment 0. Okay, so the first question: what does it mean to be authenticated but not authorized to access some web page? Okay, so in general, this is pretty simple, this question. If you take a look in the notes from CS50, here you have security. Just reminding that all of those links will lead you to those different parts of the notes, okay? It's like the same thing, just like it's just an index part to guide you to something. But let's start here in security. You can see here authorization. Authorization is the act of verifying that you are indeed the person who should have access to this account. Okay, so they are asking us, what does it mean to be authenticated but not authorized to access some web page? So to be authenticated, usually we have to use a username and a password, just like they are showing here to us, or an email address and a password as well. Once you type your username and your password and you are registered in the system, then the website will see if you are authenticated or not. If you put your username and password, and yes, you are indeed in the database from the website, then you are authenticated. But that doesn't mean that you have full access to all of the functionalities of the website, okay? And this can be in a lot of different ways. For example, if you have a website in which you have to create an account to have access to the free content that they give to you, but you have to pay monthly to get access to the full content of the website, then you are not going to be authorized to access that branch, that block of the site in which is paid, unless you pay that monthly bill, okay, to have access to this part. So once you are authenticated through your username and password, then you are inside of the website, logged in. But there are some other things that is going to say if you are authorized or not to access that block from the website. So you can be authenticated, but at the same time you can have no access to nothing from the website, or you can have full access to access and manage all of the content from the website, okay? So a good answer to this question could be, for example, dealing with the first part, to be authenticated, and then dealing with the not authorized part. So to be authenticated on a web page is the same as verifying our identity, for example. And usually this is done by using an email or username and a password. Either way, verifying our identity doesn't mean that you can access every part of the website. If you aren't authorized to use determined resources, or even the whole website itself, even being authenticated, you will not be able to interact over the website, right? Or over some actions that the site could provide to you, okay? Just like I said, for example, if you have something in the website that you're supposed to pay for, you have like a block of free things, but you have as well a block of paid things. then you are going to have access to just one block of the website. You are going to be authorized to just 30% of the website, and the rest you are not authorized, even though you are authenticated, you are logged in, for example. Okay, so let's go to the next question. If I have a 6-character password consisting of uppercase in English letters and decimal digits only, how many seconds might it take an adversary to crack, assuming they make one attempt per second? So if someone is trying to attack us, to hack us and take, for example, your password, and the attacker has to try every single possible password until it works, right? Until the password matches yours. So how many seconds should it take, assuming they make one attempt per second, right? And we have a password of 6 characters consisting of just uppercase letters, okay, from the alphabet, and decimal digits. So in here, if you take a look in the notes, we have as well defending against attacks. You can see that if you have, for example, a combination of 4 digits of only numbers, you have this operation to see how many possible passwords you could have. So if you have a password from 4 digits and all of those digits are numbers, we have numbers from 0 to 9, right? So we have 10 possible numbers, 0 until 9. Since we have 4 digits, each digit will be 10 multiplied by 10 multiplied by 10. So it's actually 10 to the power of the amount of numbers of digits that we have in that password. In this case, 10 times 10 times 10 times 10 is 10,000 possible passwords, okay? And you can see in some other cases as well. In the alphabet we have 26 letters. If we are dealing with uppercase and lowercase letters, we are considering 52 possible characters, just like you can see here, okay? So we have 26 letters, but since we have uppercase and lowercase, we have 52. And in the same way, if we have a password of 4 digits and with characters from the alphabet, uppercase and lowercase mixed together, we have to do 52 to the power of 4 or to the power of 6 if you have 6 digits. And every time that you add something different, a different letter, a different character, punctuation, for example, you are going to add to this 52, for example. If you have a slash as well in your password, you are going to consider 53 characters, okay? 53 digits to the power of 4. You can test this by using this library in here, digits from string, import digits, and then we are creating a lot of for loops, one inside of the other. So we have to check for the first digit. So once we check the first digit, for example, the letter A, we are going to test all of the letters of the alphabet in the second, in the third, and in the 4th position of our password. Since we have 4 digits, we have 4 loops. Okay, and then we can print all of the possibilities until we reach what we want. If you copy this code, for example, and paste here in VS Code, let me create here test2.py. You guys can see that if we run our code in here, Python 3 test2.py, when I click enter, you guys will see how much time the computer takes to read all of those possible passwords, which are 10,000 possibilities, okay, since we have 4 digits only made by numbers, okay. Let's click enter, and there you go. It's like a fraction of a second, and we have all the possibilities in here. You have some other cases. In this case, if we are considering all of the letters from the alphabet in uppercase and lowercase, so we have 52 possibilities. To the power of 4, we have 7 million possibilities, okay, in which we can test with this other code in here, okay. 4 iterations again, 4 digits, but we have a different library in this case, since we are dealing with the alphabet. If we paste in here, let me copy again, let me copy this again and paste in here. Now if we run our code again, you can see that now it takes a lot more of time. So you can see that we are changing here to F, G, okay, every letter of the alphabet, and we are trying all of the different possibilities in the middle as well. Okay, so we are trying every single possibility within that 7 million possibilities. So once we reach in here the end until the letter Z, we are going to start all over again with the capital A, B, C, D. Let's see, for example, Z, and now we are going to the capital letters, okay? And now you can see that we are having much more trouble to find this password, okay? And this is an example with, for example, 4 characters, 4 digits actually. Imagine a password with 8 digits, which is more common, right? 8 digits or more. If you take a look in here, once we have, if you have 4 digits as well, but now considering all of the letters, all of the numbers and the punctuation, you have 78 million different possibilities, and this is going to be much longer. Okay, so once we have the possibilities, we can see we have how much seconds this attacker is going to take to find our password, right? Considering that one attempt is equals to 1 second. So in this case, we have 26 letters from the alphabet in uppercase and 10 possible decimal digits. Then we have 36 possible characters to use in our password. Since we have a password of 6 characters, if we open up here a calculator, for example, we can do 36 to the power of 6. Okay, let's see. And then we have this huge number right here that is equals to the possibilities of passwords, different passwords that we have within that range of characters, and a password of 6 digits. And that's our answer, since every attempt, right, assuming that every attempt is equals to 1 second. So we have this amount of seconds to crack our password. All right, now let's go to our problem 3, okay? We have a pretty cool game now to play. If you take a look in here, humor us for a moment and play the password game, trying to get through at least rule 12. While obviously the game itself is in many ways meant to be humorous, it also critiques the experience many of us have setting up new passwords, explaining how there is a trade-off between usability and security in the context of passwords, okay? Because sometimes if you have like a huge password, it's going to be safer, much more safer, but at the same time it's much more easier for you, for the person, to forget that password, right? So you have to balance like a good password, a strong password, and a password that you can remember easily, right, without a lot of punctuation and numbers mixed up all together, but having a logic, right, to type your password. But let's play this game, the password game. If you click, you are directed to this new fun website. This became like a very popular game to play since the release of CS50 CYBERSECURITY. I don't know if you guys already seen this game, but it's pretty cool. So we have, please choose a password. So for example, let's create in here animal. This is going to be my password. So in here we start having rules, right? So the first rule, your password must be at least 5 characters. We passed. But now your password must include a number. So let's put 3, for example. Then your password must include an uppercase letter. So let's change our first A to uppercase. Your password must include a special character. Let's add a dot in here. Your password, the digits in your password must add up to 25. So the digits altogether should be equals to 25. So let's put 3, 9, for example. We have 12. Let's put 6. We have 18. Let's put 2. Okay, we have 20. Let's put 5. We have 25. Now we have a lot of numbers. Your password must include a month of the year. Let's add, for example, January. Okay. Your password must include a Roman numeral. So let's put X, for example. Your password must include one of our sponsors. So let's use Pepsi in this case. Pepsi. Okay. The Roman numerals in your password should multiply to 35. So we can use 7 times 5 in this case. So let's use 5 in here. 7. So 7 is like 5 plus 2. So let's use 5 plus 2. Okay, so 7 multiplied by 5 is 35. So now your password must include this CAPTCHA. So we have F75CX. Okay, we passed. Now we have the row 5 again. So the digits in your password must add up to 25. Since we added 2 more numbers, now we are not adding up to 25. But let's keep only that 5 from there. Okay, since we have this 7 in here, let's remove this 6. Let's remove this 9 as well. And let's put another 7 in here. Now we have 25 again. Your password must include today's Wordle answer. If you guys don't know Wordle, it's another game, pretty cool game. If you copy and paste here on Google and you play, it's from the New York Times. Okay, let's play, and now let's find out the Wordle game. Okay, the password from the day. So first you can put like a phrase in here, a word, and then you can see in here if the letter is like this yellow, it means that the letter is in the right word, but it's not in the right position. If it's green, is in the right position and it's inside of the word. So we have an H. Okay, so let's use house, for example. Since it's in the wrong place, let's put house. Okay, so the U, we just got it right, so U in the middle. Okay, so the U in the middle, let's use truth, for example, truth. Okay, so you just have it right, okay, so truth, okay, in the third attempt. So let's use truth in our password, truth, okay, now we passed. Your password must include a 2-letter symbol from the periodic table, so let's use LI, okay. Now we have some other rules. Either way, you can keep playing, right? They just ask us to play at least to the row 12, and by the end you can see that your answer is like very long and it's like almost impossible to remember, right? We have animal and a punctuation, numbers, a month, the name of a month, for example, then we have Roman numerals, then we have Pepsi. It's almost impossible to remember. And this is actually the lesson they are trying to show us, right? And they ask us, explain how there is a trade-off between usability and security in the context of passwords. Just like I told you, we don't even have to take a look in the notes, but you have to balance your password. Since we saw here in the logic of finding out how many possible passwords you can have with a 4-character password, a 6-character password made of just numbers or all of the alphabet, you can take a look at that. Once you have a 6-character password or an 8-character password, you already have a very secure password. It's going to give a long time if anyone tries to hack or to find out what is your password. Easy to remember, but at the same time, a safe password, right? So in this case, we should have a pretty good answer. So if you can create like a password with 20 characters, mixed between numbers, letters in uppercase and lowercase and punctuation as well, you are more than secure, right? It's a very good password. It's very long, right? It will take a lot of time to crack this password, but at the same time that you are secure, it will be very easy to forget all of the password after a while. Nobody wants to write your password on something and have to reach to that note every time that you want to log in a web page, right? That's why it's very common to use passwords with around 6 or 8 mixed characters, right? To balance safety and still have a short key, a short password, making a very balanced password between security and usability, right? Okay, guys, now we have in the other questions, we have some questions that we already discussed in here, and we put just like a proof in the VS Code, right? So we have in here a comic, okay, in which we have like a short password with a lot of things mixed together, numbers in the middle of characters. Then we have punctuation as well, in like a random order of things, okay? So in here we have like a small password, and we can see here a little calculation to see how many time it would take to crack our password, and we can see that it would take 3 days at 1,000 guesses per second. So it's easy to crack, right? You just leave your computer for 3 days and you are going to receive the password of the person, right? But it's very hard to remember, okay? So you have in here something that actually makes fun of the guy trying to remember the password. So it's very hard to remember since we have things mixed with a random order of things. It doesn't make sense, right? And in here we have a much longer password, but we have like a sequence of things, right? Things make sense. We have first a word, then a second word, a third word, a fourth word, but all together. But we have a sequence of thought to create this password, right? So it's pretty long. It will take like a lot of time to be guessed. In this calculation, it will take 550 years at 1,000 guesses per second, so it's very hard to crack. And at the same time, it's very easy to remember. You can take about something correct, then you can think about a horse, then a battery, then a staple. In this case, this should come together. Just like I said, sometimes you can use a name of someone, for example, and the date of your birth. It's very, very easy to remember, right? In this case, at the same time that you have a long and hard password to crack, you have a password that is easier to remember, although it's longer than the first one. So here in the question is actually the same thing that we discussed in those two first questions. Okay, consider the top row of the comic above. Why are passwords like those easy for a computer to guess, but hard for a human to remember? So they are telling us about this first row in here. We could answer this just using what I just told you guys. So we could use, that is the perfect example, the first row, right, of a non-balanced password. You have a key with different types of characters, but it's not long enough. Then the computer won't have a rough time cracking it, and it's totally the opposite for the person to remember, since you have numbers, letters, punctuation all mixed up, very easy to forget. And they are not just mixed up, but you don't have like a thought behind the making of this password, so you're not going to remember very well. But the computer, since the computer will try every single possibility, it will be easy, let's say easy for the computer to crack this password, since we don't have so much characters, okay? Now in the opposite way, in the next question, we have now considered the bottom row of the comic above. Why are passwords like those hard for a computer to guess but easy for a human to remember? Just like I explained it as well, okay, we could formulate our answer talking about something like the second password is actually balanced, right? Because it's very long, increasing the amount of time for the computer to crack, more than 550 years, just like they showed us doing that logic, right, for discovering, and it's composed of just simple and usual words, being easier for the person to remember and getting the logic all together, right? Keep in mind, right, that having a very long password can be good in this case, because it will take a long time for a computer to crack this password. But if you don't have like a logic of thinking behind this password, you can fall in the same mistake of creating a long password, but at the end you are not going to be able to remember this password. So be very aware of this, okay? So next question, we might say that a website leaks information, right? What sort of information might a poorly designed website actually leak in practice? Okay, so leak of information, it's the same thing as having our password, for example, cracked. Or like all of the passwords to authenticate people to get inside of that website is always stored inside of a database, and this database can always be vulnerable to leak that info if it's poorly designed. So in practice, this leaks happens in this way, okay? So in this case, we can think about how this should happen. And we can say that leak information actually means that an unauthorized person can access other people's credentials, right? And this can be very dangerous to the privacy of the users. Usually when the website is poorly designed, there's a lot of info that can be leaked, like names, email addresses, phone numbers, home addresses, and in a very harmful situation, even credit card information. Those are data that in the wrong hands can be very harmful. So if you have, for example, the information of your credit card leaked, you are going to have a rough time trying to recover from this. Okay, the attacker can do whatever they want with this info, buying things online or even clone your credit card, in which most of those cases it's what happens in these cases, right? But let's go to the other questions, okay? We have in here, provide an example of something that would be considered a knowledge factor. And I'm going to get this question together with this other one, provide the next question as well, provide an example of something that would be considered an inherence factor. Okay, now if you take a look here in the notes from CS50, if we go down here to two-factor authentication or multi-factor authentication, right? I think you guys are familiar with this. Nowadays you have this two-factor authentication. It's not like mandatory, but it's something that gets your account much more secured. It doesn't depend on something that you remember, right? Or something that it's a password that can be fragile depending on the complexity of the password. Just saw that some passwords can be very easy to crack or to find out. So when you have two-factor authentication, sometimes you can have ways to identify that it's something that only you have access. For example, your phone, in which a message will go directly to your phone number, or something even biological, right? Using your fingerprint or your eye, for example, and these kinds of things. So you can see here that there are three components of multi-factor authentication: knowledge, something only you know, for example, a password, and an email address, for example, a username, possession, an item or device only possessed by an authorized person, an authorized user. Okay, for example, just like I said, the cell phone, right? Only you have the chip with the number on your cell phone, okay? And inherence, only a factor you could obtain, like your fingerprint, face, or other biometrics, something biological in this case, right? So in here we can answer both of those questions. So provide an example of something that would be considered a knowledge factor. Okay, we could say that nowadays you have a lot of steps to get authenticated into a web page, right? Between those methods, you have what is considered a knowledge factor. This is data that depends on something that the user knows. For example, the password or the email address. But of course, it's something a little bit fragile, right? And at the same time, we have provided an example of something that would be considered an inheritance factor. So we have the biological side of this. So biometric authentication can be considered an inheritance factor that gets a biological trait to authenticate the person. Inside of those biometric methods, you can use fingerprints, facial recognition, voice recognition, and even behavior from the person. Okay, in this question, they are not accepting more than 40 characters. Okay, so we can go right to the point. I just elaborated a more complex answer just so you guys can understand a little bit better, but in here we can just write right away what's considered a knowledge factor. In this case, can be a password or the email address to be authenticated. Okay, and in here provide an example of something that will be considered an inheritance factor. We have a max of 40 characters, so let's put in here facial, voice recognition, and fingerprint. I just reached the 40 characters. Let's put facial, voice recognition, and fingerprints. Let me just use a comma here. And fingerprints, just like that. Now we have 3 of different examples. So facial, voice recognition, and fingerprints. Okay, so in here, let's go to almost the last question, in which we get to the last concept from this assignment, right? It's pretty simple. Why are phishing attacks so difficult to prevent? Okay, if you take a look here in the notes, you can see down here, phishing. Phishing uses social engineering in a technological way to obtain your credentials and details by posing as a trusted website. So in this case, they are not going to use a code or some program to crack your password, for example, but they are going to use to pass posts by trusted people, okay, from big companies. Okay, for example, you may be directed to something that looks like a Google login page, but is in fact an adversary's page. Okay, so it can be not one-on-one, so direct with the attacker. Can be like a link with a website that looks like the original website, but it's not. Or it can be, for example, a phone call from a bank asking you some personal information, saying that you have some problem or you have some bills to pay, and if you don't pay, you are going to get in trouble. And then they can actually get this info from people that is not very aware of that danger. Okay, so that's actually what phishing is. Okay, so why is so difficult to prevent? Okay, just like I told you guys, those kinds of attack, they're very easy to fall and not prevent, because usually they use a website very alike with the original one, or people that call you, offer to you, or say some things to you that actually makes you believe that it's something very legit. And when you see you have already passed your email, your password, your credit number, some things like that, and it's already over, you just got attacked successfully. That's why it's so difficult to prevent a lot of times to people that is not very aware with this technological thing. Okay, so we could formulate this just like I told you guys. Once the person is like a victim from the attack, the attacker will get access to her information because the person herself sent it to him, right? Because the person was thinking that was something legit and not a person posing as an employer from that company. Okay, at the moment that the attacker poses as a trustworthy entity, it becomes very difficult to realize or prevent the attack, right? And once he has hands on the person's information, it's even harder to solve all of the losses from this attack. Why it's so difficult to solve after you have already fallen into this attack? Because you by yourself gave this information to the person, believing that this person was indeed a part of this company, but it wasn't, right? And once you see, you can have already sent money to that attacker, and then it's very difficult to get it back. Okay, but in general, that's why those attacks are very difficult to prevent. Okay, now we have the last question, a question that it's going to depend more of you guys. You can create a whole scenario for this question. So suppose that your boss's boss asks you whether the company should require use of password managers for all employees. Explain in a short paragraph why you might want everyone in the company to use a password manager. So you guys can take a group together all of this that we just discussed in this assignment, right? Some things about securing your password, creating a good password, but at the same time you be able to manage this password, remember it easily, and some things that you can do to prevent a attack, okay? And then you can make by yourself this paragraph of why you can actually pretend that you are explaining to your boss's boss why you should have a password manager in the company. You can pretend that you are sending an email, you can pretend that you are speaking one-on-one with your boss's boss, okay? And then you can formulate the answer. In my case, I formulated a answer just like this, requiring, okay, so I would say requiring all employees to use a password manager is a proactive way to improve cybersecurity in the company, right? A password manager can generate strong passwords and manage them so the person doesn't have to, using, for example, an autofill in the company's computers, right, with the employees, to make it easier, right? This approach significantly increases the defenses against leaks to avoid attacks on the user's information, which is very important since this information, the user's information, sometimes can mean the same thing as the company's information, right? Additionally, password managers help simplify password management and relieve employees of remembering complex passwords, reducing the risk of data breaches and unauthorized access to company information, okay? In general, that's what I thought I would say to my boss's boss. Of course, explaining a little bit more why you can have these data breaches, and when you have a password manager, you don't have this problem, because people will remember the password and you have the possibility of getting the password much more safer, creating longer passwords, since the password manager will help the person to remember if in any scenario the person forgets. For example, this is just one of the usability you can have with this password manager, okay? But you guys can formulate and create your own explanations, right? And try to convince your boss's boss to implement this into the company, okay? Now we just finished. You have some feedback in here. How did you find the difficulty of this assignment? Let's give a 3, for example, okay? It wasn't too hard, okay? About how many minutes would you say you spent on this assignment just to set expectations for future students? Let's say, for example, 60 minutes, right? Okay, guys, so we are done with our assignment. After you finish your answers, you can send in here, and then just like they told you, they are going to see your submission, and after a while they are going to send you an email telling if you passed or not the assignment. But that's it for this first assignment. It's actually a pretty easy assignment. It's something more introductory, right? But now we are going to work with some other things after a while here in our YouTube channel, just like securing data, securing systems, software, and preserving privacy, okay? All of those things inside of cybersecurity. So if you have any doubts about this first assignment, leave here in the comments. We will be answering you guys, and I see you guys in the next video from cybersecurity, okay? Bye bye.